Okay, good afternoon. It's afternoon here wherever I am. Okay, so I'm going to continue on Unit 4. We are looking at data warehousing today, and that is what we're going to look at, and we're also going to look at OLAP, and that will complete Unit 4 that we started last week, and then we move on to Unit 5 as well. I would give a comprehensive lecture on those three. That is the data warehousing, the OLAP, and the ERP implementation cycle. So the data warehousing and OLAP is a completion of Unit 4 that we started last week, and then the ERP implementation cycle is Unit 5, and then we'll be done with the syllabus for management information systems. So I hope every one of you benefits from this one. Not that to say that no, Mrs. Banda didn't finish the lectures. I am completing them now. Please be attentive. They are short lectures, and so they won't take much of our time. So we are looking at data warehousing as a continuation of Unit 4 from last week. And so what is data warehousing? So by definition, it is a centralized end repository channel, or I would say a channel, where it is designed for querying, it is designed for analysis, as well as for decision making. It is not designed for transaction processing. So a data warehouse is a centralized integrated repository designed for querying, for decision making, as well as for analysis. Please bear in mind, it is not meant for transaction processing. Okay, if we go by the definition of Bill Ilinon, in MON, we see that data warehousing is actually a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management decision-making processes. That is according to Bill Inmons. Okay, so we look at the key characteristics of data warehousing. The first one, it is subject-oriented. So when we say it is subject-oriented, what do we mean? It focuses on the business's main domains like finance, like HR, like customer services, like sales, and so on and so forth. So it is really subject-oriented. So what that means is that in a particular domain or in a particular query, you would be able to get information according to sales, you'd be able to get information according to finance, and should not be lost. Secondly, it has an integration, or it is integrated, meaning that it measures data from diverse sources. You are able to get information from the various departments that the organization has. As a result, you have a unified format. Okay, then it also has a time variant. Okay, it has a time variant, meaning that it is able to collect historical data. Okay, typically with timestamps. Okay, so when we say that it's time variant, the moment that a transaction took place, say for example you sold out bags of maize, it will indicate Chimwemwe sold out bags of maize, 15 bags of maize. It will also include the time at 15:53 on 12th March 2025. So it has the time stamp, the time variant clearly stipulated when you draw out your report. Then fourth characteristic is that it's non-volatile. Okay, it is non-volatile, meaning that the data, once you have input it, it remains unchanged. Okay, so um, once it is entered, it remains as a read only. You cannot manipulate it. So it has 4 characteristics. The first one being that it is subject oriented. Secondly, it's integrated. Thirdly, it's time variant. And fourth, it is non-variant. Okay, non-volatile. Okay, those are the 4 characteristics of a data warehouse. Okay, let's delve into looking into its importance and its purpose. Okay, we look into the importance as well as the purpose of a data warehouse. Basically, they are 4 as well. Okay, they are 4. The first one being that it enables business intelligence, okay, and data-driven decisions. I think last week we looked at business intelligence, so at least you have no excuse into asking that what is business intelligence, okay? Secondly, it supports strategic planning, it supports forecasting as well as performance tracking. That is the second purpose as well as importance. The other thing is that it helps in historical trend analysis as well as future predictions. You are able to do a trend analysis and you are able to do a future prediction. Okay, and fourthly, it centralizes data from the systems like ERP, like CRM, as well as legacy apps. So what we're going to do is delve into explaining more on the purpose and the importance, beginning with the fact that enables business intelligence and data-driven decisions. What are we saying? A data warehouse, okay? It serves as the foundation for business intelligence, okay? It serves as the foundation for business intelligence, and these are the tools as well as the analytics. So by consolidating, okay, and organizing data from the various sources where information is coming from into one centralized location, it allows the organizations to make multi-dimensional analysis, okay? The organization can perform a multi-dimensional analysis, and it can be by product, it can be by time, it can be by cell. So because it enables the business intelligence and data-driven decisions, there's that capability that a company can do. Secondly, you are able to generate insights from the dashboards. Why? Because everything now has been brought together and it has been put in a central place. So you are able to monitor the KPIs as well as the performance indices that are within the organization. And then it will also empower the executives, okay, to make informed and timely and strategic decisions, okay, based on the comprehensive information that is in the data warehouse. So that is the first purpose, whereby we are saying it enables business intelligence because it has data-driven decisions. Okay, that's the first purpose and the importance. Secondly, what we are looking at is that it supports strategic planning, okay? It supports strategic planning as well as forecasting as well as performance tracking. So it supports strategic planning, performance tracking, and forecasting. So data warehousing actually enables the organization to evaluate both the past and the current performance, okay, across all the departments, be it sales, be it operations, be it administration. They are able to evaluate the past and the current performance. Secondly, it will perform a what-if analysis, okay, a what-if analysis, and this is to anticipate if at all there are any future scenarios or outcomes that may be rendered necessary. Okay, then you plan resources more effectively by identifying the seasonal trends. You see, trend analysis comes in again because you have customers' behaviors that you need to look into as well. You need to look into the market shifts that are happening within an organization or within the surrounding, the environment. Okay, then you also need to track the organizational goals because each and every organization has got objectives that they want to fulfill. And so if you have a data warehouse, you are able to track the organizational goals, whether they have been met or not. And then you also align the operational strategies that you have put in place with the long-term business goals, and that is because you are using data-driven evidence. So it supports planning, it supports forecasting, as well as performance tracking. Okay, thirdly, it helps in historical trend analysis and future predictions. Okay, so unlike the operational databases that store data, data warehouses store historical data, okay? And it stores it over a long period of time. So you have a detailed trend analysis if you are to get your information from a data warehouse. Why? Because it follows a certain pattern and you are able to derive things such as increasing purchase returns, or you are able to see whether the customer lines are declining. All those things you are able to take note if at all you have a data warehouse. On the other hand, you have a comparative analysis across the multiple time period regions or even just business units. Okay, then you can use time series. You can use time series to make forecasts into sales, budgeting, inventory management, as well as customer demand. Thereby, you have a better understanding of the business cycles that would help you to reduce the risks and identify the growth opportunities. So that is the third purpose and importance of a data warehouse, because it will help you in historical and trend analysis and future predictions. Brings us to the fourth purpose and importance, which is it centralizes various data from different systems, okay? It centralizes data from various systems. So when we talk about various systems, we are looking at the ERP, we are looking at the CRM. Such are the things, or such are the systems that we would look at. So when you look at modern organizations, okay, they use various systems for different functions, okay? They use various systems for different functions. So you use the ERP system that will handle the finance, that will handle the procurement, as well as the operations. Then you use the CRM system that will manage the customer relationships and the other interactions that the organization is going through, okay? And then you use the legacy databases, okay? The legacy databases may contain critical but outdated formats or systems that the company previously used. So a data warehouse kind of like brings all this information together and standardizes the data. Okay, so from all the sources of these all the sources of information, from the various sources of information, all this information is brought together and is used in a single, okay, in a single format. Thereby, it ensures that there is consistency, okay? The aspect of consistency comes in as well as accuracy. Why? Because across the reporting lines and the analytics that are happening within the organization, everything has been unified and everything is uniform. Okay, then there's also an elimination of data silos, okay, promoting collaboration and transparency into a single format that is across all the departments. And then there is a reduction of manual reconciliations and efforts that are taking place. Why? Because now this will lead to greater efficiency and effectiveness, as well as reliability in carrying out any analysis. Okay, so a single source of truth, SSOT, okay, for the entire organization, which enhances trust and data-driven decision making. So when we talk about a single source of truth, SSOT, it means that the information that will be derived from the finance department is the same information that is going to be derived from the HR department. Why? Because of the uniformity of information, the information does not change. It doesn't say that, no, this information is for the finance department, let me include other details. Or it doesn't say that, no, this information is for HR, let me include other details. So there is uniformity in the way information is displayed, or any way that an analysis is done, there is uniformity. And you cannot run away from that. Okay, so those are the 4 purposes and importance of a data warehouse. We move on and look into the components of a data warehouse. Okay, components of a data warehouse. So the first component is data sources. Okay, ERP, CRM, spreadsheets, databases, all these are components of a data warehouse. Secondly, we have the ETL process, where you extract, you transform, you load. That is ETL. You extract, you transform, you load. Okay, so it preps data for the warehouse. Okay, then there is the staging area. The staging area, there is a temporary storage, okay, for cleaning and transforming data. So in this area, you can edit, but once it is transferred to the data storage, to the main repository, it means there now you start using what they call schemas like star or snowflake. Okay, then we also have the metadata. The metadata is info about data, the sources, the meaning, the updates. These are all scheduled in that place. Then we also have the query tools such as the dashboards, the SQLs, and the OLAP reports for end users. Okay, so those are the main characteristics of a data warehouse. So we have the data sources, we have the ETL process, we have the storage, the staging area, we have the data storage, the metadata, as well as the query tools, bringing us to data warehouse architecture. Okay, so when we talk about data warehouse architecture, we are just looking at the way a data warehouse can be made or formatted. Okay, so the first one is a single tier, where you have everything in just one layer. Okay, and then there's the two tier. Okay, so it separates the storage and the interface. The user interface and the storage are separated. So that is the 2 tier. Then we have the 3 tier, which is the most common. So you have the bottom tier, where you have the data warehouse and the database. Then you have the middle tier, where you have the OLAP server, as well as the access tools. And finally, you have the top tier, where you have front-end tools, okay, such as the dashboards and the queries. Okay, so those are the 3 different types of warehouse architecture: the single tier, the 2 tier, and the 3 tier. And where the 3 tier comprises of the bottom tier, the middle tier, as well as the top tier. Okay, schema types. Schema types, there's the star schema, there's the snowflake schema, as well as the galaxy schema. So the star schema. Okay, it's a central fact table linked to dimension tables. Okay, it's a central facts table, and then it's got links to dimension tables. That's how it looks like a star, just the way the star is. That's how the schema is. And then there's the snowflake schema, okay? Normalized version of star schema split into subtables. So the way the star is, yeah, the way the star is from the dimension tables, probably you have other outlets into subtables. That's what it basically is. And finally, you have the galaxy schema, where you have multiple fact tables sharing dimension tables. So it forms like the way we see the constellation in the sky in the night. So it's just scattered all over, but there's information that is going here and there. Okay, so now we want to make a comparison between the data warehouse and the operational database. Okay, we want to make a comparison between the data warehouse and the operational database. Not too many differences, but a few similarities here and there. So when we talk about the purpose of the data warehouse, it lies in analyzing and reporting. When you look at the operational side of the database, what do we see? We see real-time transaction processing. So when we talk about the purpose of a data warehouse, there's analysis and reporting. When we talk about operational databases, we find real-time transaction processing. Then the second feature is data, okay? The data in a data warehouse is historical. The data in an operations database is current. Then we look at the structure. The structure of the data warehouse is denormalized for speed, okay? It's denormalized for speed. And then in an operational database, there is the normalization for consistency. Okay, those are the major differences. And then we talk about the users. The users of the data warehouse are usually the analysts and the executives. Okay, and the users of an operational database are usually the clerks as well as the day-to-day operators. Okay, those are the major differences between the data warehouse as well as the operational database. Okay, coming to the benefits. The benefits, we look at the area of business decisions, okay? The benefit of a data warehouse is that you have reliable information, you have integrated data from all the sound decisions that need to be made, okay? So there's the business decisions area. The second area of where the benefits lies is in the performance. In the performance, you have faster queries for large data sets, okay? You want to query something because the information is there in the data warehouse. It is historical, it is current. You can get a faster answer to any query that you have. Thirdly, you have a historical analysis, okay? So it enables you to see the trends of business that have been taking place, as well as it can enable you to make a forecast into making predictions of what you would want the business to look like. And then there's also data consistency, okay? You have unified data format for all the different sources. From all the different sources, you have a unified data format. And lastly, you have productivity, meaning that you have less manual effort in collecting as well as reconciling data. So to run through the benefits of a data warehouse again, first, you have business decisions, which are efficient, reliable, integrated. Second, you have performance which can be monitored, especially in terms of getting faster queries, okay? Thirdly, you have a historical analysis where it enables trends analysis as well as forecasting. And thirdly, you have data consistency. Why? Because you have unified data formats as well as information from different sources. And lastly, you have productivity because you have less manual effort that is being employed into the business to collect as well as reconcile data. Okay, so those are the benefits of data warehousing. Let's come to the challenges of data warehousing. Okay, the challenges of data warehousing. The challenges of data warehousing. The challenges of data warehousing include: one, the high cost and complexity. Okay, it requires an upfront investment and a design. So we looked at the architecture. We said there's a 1 tier, there's a 2 tier, there's a 3 tier. Depending on what you decide on, there is always that high cost and complexity that these things come with. Secondly, you have data integration issues, okay? Data integration issues. So different source formats and quality become an issue, all right? Then you have data quality as well as governance, okay? Accuracy, cleanliness, and consistency matters, okay? So those pose as a challenge. Then you have performance tuning, okay? Large volumes of data can slow down queries, okay? Large volumes of data can slow down queries. And then the last one is user adoption. Training is needed for non-technical users. So that poses as a challenge under data warehousing. Okay, so the challenges are high cost and complexity, data integration issues, then you have data quality and governance, you have performance tuning, and finally you have user adoption. Okay, so that wraps up data warehousing. Okay, that wraps up data warehousing. We move on to OLAP, online analytical processing. Online analytical processing. By definition, online analytical processing refers to the class of technologies, okay, that enable interactive, multidimensional analysis of data in order to support business decision making, okay? This was actually introduced by Edgar Code, who emphasized its value as well as the need for analytical rather than transactional environments. So Edgar Code emphasized its value in analytical rather than transactional environments. So you see that OLAP, online analytical processing systems, are optimized for complex querying and reporting, not for routine transactional tasks. Okay, they are optimized for complex querying and reporting and not for transactional tasks. Okay, so that is the online analytical processing. Okay, the online analytical processing. Let's delve into the purpose. What is the purpose for an OLAP? Okay, so firstly, it's to provide fast, flexible, and interactive analysis of large data sets. So it's to provide fast, flexible, and interactive analysis of large data sets. Secondly, you need to empower users to slice, to dice, to drill down, and to roll up, okay, and pivot data, okay? It empowers users to slice, to dice, to roll up, to drill down, and to pivot data. So meaning that you can look at information from whatever angle and still be able to get the correct information that you need. And then it is there to support strategic and tactical business decisions. Okay, so through the multi-dimensional perspectives such as sales by region, by time, or by product, there's that aspect where you are able to make strategic and tactical business decisions because the whole system is multi-dimensional. Okay, so key features of an OLAP. Key features of an OLAP. Okay, so like I have mentioned already, it's multi-dimensional. It has that multi-dimensional analysis. Why? Because it organizes data from various departments into cubes with dimensions like time, like product, or even just the location. Okay, so it is multi-dimensional. You can choose from which angle you want to analyze the information that you want. Secondly, it has a fast query performance. Okay, it uses pre-aggregated data to reduce the response time for complex queries. So you may have complex queries, but they can be dealt with faster. Then there is also the data navigation. Okay, users can explore data at different granularities. Okay, they can explore data at different granularities. So you want to get information pertaining to procurement and procurement of a specific product, same maize. You can categorize it according which area gave us, which location gave us more maize, which brand of maize was used, was it Sitco, was it Pana? So you can navigate through the information to explore various granularities. Yeah, so there's also that consolidation or roll-up, okay, whereby this aggregates to a higher level of information. So you can get daily information, you can get monthly information, quarterly or yearly. It depends on how you want to consolidate the information. So you can compare last month, April, compare it with last year's April. Such kind of consolidation and roll-ups could be done. Then there's also the drill down. The drill down, which means that it explores detailed data from summary level, okay? From summary level. So you can summarize the year, you can summarize the month, you can summarize the quarter in that manner. So you can drill down. Then the slicing is the extraction for a specific subject, okay? So you can say sales in quarter one or sales in quarter two, such kind of thing across all regions. And then there's the dicing, where you analyze a subcube, okay? So you can say quarter one sales in region A for product B, okay? Such thing. So you are dicing up the information. So we want to compare an OLAP, online analytical processing, with online transactional processing. OLAP versus OLTP. Okay, so OLAP is analytical, OLTP is transactional. Okay, so the purpose for the two. So the analytical one deals with complex analysis, okay, and decision making. And the transactional one deals with daily transaction processing. That is the purpose. Those are the differences. Then when it comes to data, the data in an OLAP is historical, it is summarized, as well as multi-dimensional. In an OLTP, the data is current, it is detailed, as well as normalized. All right, that is the difference where the data is concerned. Where the queries are concerned, the OLAP is complex, often ad hoc, and multidimensional. And in the OLTP, it is simple and predefined. Okay? Those are queries. When it comes to the users in an OLAP include the business analysts and the executives. Then in an OLTP, you have clerical and front-end staff. Okay? Then examples of an OLAP is that you have a sales forecasting, you have performance trends, then in an OLAT you have ATM withdrawals, you have product orders. Okay, those are the examples in the two different dimensions. Okay, so let us look at the architecture. The architecture types of an OLAP. The architecture types of an OLAP. So we have a MOLAP, which is a multi-dimensional OLAP. So data is in this one is multi-dimensional and it is optimized into cubes. Okay, so the pros of this one is that it's very fast, it's got good performance as compact storage, but the disadvantage of this one is that it has got limited scalability for massive data sets. Okay, then when you look at the ROLAP, the rational OLAP, okay, data is stored traditionally, okay, so it is a relational, okay, I said a relational OLAP, so the data is relational, so the databases are relational, and then they have a real-time SQL. Okay, so the pros of this one is that it handles large data volumes and is flexible, and then the disadvantages is that it's slower, it has got a slower query performance compared to the MOLAP. Okay, the multi-dimensional or online analytical processing. Yeah. Then you have the hybrid, which is referred to as the HOLAP. Hybrid OLAP combines both the MOLAP and the ROLAP. Okay, so you have the summary data, you have the detailed data, all compressed into one because it is hybrid. Okay, so here you have a balanced speed and scalability, and then on the disadvantage parts you have slightly more complex to implement as well as to maintain it. Okay, so the online analysis processes, architecture types, you have the MOLAP, you have the ROLAP, and you have the hybrid. Okay, so OLAP, operations or functions, okay? The operations or functions. What are we saying here? Okay, the slicing. When we talk about the slicing, so it selects one dimension, okay, to filter the cube. Okay, so an example would be like view all sales in quarter one or view all purchases in quarter one. That is a slice that you would take out. And then the dicing would say it filters the cube on multiple dimensions. So you say view sales in quarter one, and then you're also saying in region A, and then you're also saying for product B or product X. Okay, so there now you are dicing up just to get more information. So when we talk about drilling down, so it moves from summary level and moves up to detailed levels. So you can start from the year, then move on to the quarter, then to the month, and then to the day. That is drilling down. And then when you are rolling up, you are aggregating, okay, from detailed to a higher level of summary. Thereby, you can move from the day to the month to the quarter, then to the year. Okay, and then you have the pivot. When we talk about the pivot, it rotates the data. Okay, it rotates the data cube in order to change the dimension or perspective. So you're switching from viewing sales by region, product, to product and region. Okay, so what are we concluding on OLAP? Okay, what are we concluding on OLAP? We are saying the OLAP systems are an essential tool for both the business analysts as well as the essential tools. So the systems are essential tools for business analysts, okay, because the analysts at the end of the day are enabled to make better strategic decisions, okay? They are able to make better strategic decisions. They are able to analyze data across the dimensions effectively. They are also able to unlock insights, okay, that are difficult to see with a flat transactional data alone. Okay, so that is the OLAP, and that is the data warehousing that we were looking at in Unit 3, and that in Unit 4, and that concludes Unit 4. Okay, so that is data warehousing and the online analytical processes. Okay, so we'll end there. Thank you very much. I shall carry on and look into Unit 5, and you'll be able to get some insights on the ERP implementation cycle. So thank you, and have a blessed day and a good day as you continue to study for your exams. Please study extra hard. These courses are not difficult. Just put in some extra and you will be good to go. Thank you, thank you, thank you.